This is a teacher summary for Unit 3, Lesson D, Triangles and Parallel Lines. You want to have your ringlet reference handy. You should be looking on the other side. So these two pages are already completed. If they are not, you should get your information from a classmate. We're now on this side, and we're going to be zeroing in on what happens when triangles are sliced by parallel lines. When triangles sliced by parallel lines. So what I'd like you to do is get a straight edge, and we're going to slice this triangle with the parallel line. So we know this line is parallel to that line, or make it so. Now there's two ways I want you to view this scenario. There's two separate perceptions. One, when triangle is sliced by a parallel line, the first method I'd like you to see is the fact that you have two overlapping similar triangles. Two overlapping similar triangles. So in this case, you have the green triangle, and then the larger overlapping triangle. And again, this is created by the parallel lines. These triangles are similar. So that's the first way I'd like you to view, is that you have overlapping similar triangles. And the reason why they are similar is, one, they both share angle Q. That's reflexive. And the second reason is because of the parallel lines, they have corresponding angles. So in this scenario, they are similar by the angle-angle similarity shortcut. So one way to view when a triangle is intersected by a parallel line is the fact that you have similar triangles. The triangles are similar. Now another way to look at this is, instead of seeing overlapping triangles, it's just on the non-parallel sides of the triangles, just see these segments here. These segments. These pieces on the non-parallel side. So you're not looking at triangles, you're just seeing these segments on the side. Those are also proportional. Then the segments created by the parallel side are proportional. So instead of seeing it as overlapping triangles, you see just the segments and the fact that you can make these segments proportional. Exact same diagram, two different ways to perceive it. Again, it's like the old hag versus young lady optical illusion. So let's do two problems. That'll go on your ringlet card, and then we'll do two more problems. So on the left, we have here, whenever you have the parallel line slicing, as it is, and you have information on the parallel sides themselves, we're going to trace and pull apart these triangles. So we're going to trace this. We have the green triangle. And then we have the overlapping pink triangle. Let's get our numbers here. So that is 55, 33. This whole long side here is 50. Careful, in the green, that is not 20. It's going to be 50 minus 20, so that's 30. Then we have this whole side, which is 30. And we're being asked to find this, which is our unknown. I'm going to take that unknown and just call it x, because that's what you're used to. So now, knowing these triangles are similar, we can make a proportion. So I'm going to go left over right equals left over right. So I'm going to go 30 to the 50, left over right, equals unknown to the 30. Now you cross multiply. We end up with 50 equals 30 times 30, 50x, excuse me. The key to multiplying is not multiplying. So here we're just going to divide by 50. Watch carefully. The zeros, or a set of 0 cancels. Circle the 5 and circle the 30. 5 goes into 36 times. So now we have 3 times 6, x equals 18. So our unknown right here is 18. So that's one way, is to pull the triangles apart and see them as two separate but similar triangles. Another way you can look at it is just having parallel lines. So when you do work with the parallel lines, you always want to stretch those parallel lines out. So on the right, we're just going to stretch the parallel lines out. I'm just going to add one more parallel line so it's easy to kind of visualize it. So these segments here are all proportional. So we're going to make a proportion. Now the name of the game here is to match and mirror. Match and mirror. Say that with me. Match and mirror. So watch very carefully here because there's a trick to this. Ready? So we know this whole side is 18. So I'm going to 18 over what I want, which is my unknown. I'll call it x. Now careful, you can't just pick up 4 here. Match, since this is the whole side here, we have to go the whole side over here. The whole side here is 4 plus 5, which is 9, over the bottom, which is 5. Why do I choose 5 and not 4? That's in the same position as my unknown. Match and mirror. Match and mirror. Now we cross multiply. So I have 9x equals 18 times 5. Key to multiplying is not multiplying. It's reducing. I divide by 9. Get really close here. Circle 9 and circle 18. Let's reduce that. 9 goes into 18 twice. Circle the 2 and the 5. Those multiply, and x, or the unknown here, is going to be 10. So again, what are we looking at? We're perceiving the same diagram two different ways. One with similar triangles, one with parallel lines and segments. Let's go to your notes and do 2 more problems. Okay, so here we want to find the length of DE. Now DE is on one of the parallel segments. So when you have something that's working on a parallel segment, we need to pull them apart. So the first thing we're going to do is we're going to trace the triangles and we're going to pull them apart. So trace and pull apart. and then trace, and pull apart. Now be very careful when you bring your numbers over here. Here, this is DE, this is our unknown. That's what we want, we'll just call it X. And then here, the short piece is 27. Here, this is 28. This side's 36, and be really careful here. This is not 18. That whole side is 18 plus 27. So we add that up, 15 carry the 1, and we have 45. Now, they are similar. So trace, separate, now we're going to make side over side and solve. So let's make a proportion. So I'm going to go X over 28, left to right equals 27 over 45. Now you just cross multiply and solve. Don't even dream of getting a calculator right now. Hands off the calculator. Just because there's 2 digits here does not make this harder. 45x equals 28 times 27. Don't panic. Relax. No calculator. Watch carefully. We're going to get x by itself. Now ready? Let's reduce this together. Circle the 45, circle the 27. We know 9 goes into both. So 9 goes in here 5 times, and 9 goes in here 3 times. Okay, so now we're going to do 3 times 28. That, of course, is 4. Carry the 2, and that's going to be 84. So I have 84 divided by 5. Yes, we're doing this longhand division. It's good for the brain. Ready? 5 goes into 8 1 time. 3 left over. Bring down the 34. 5 goes into 34 6 times, which is 30. Bring down the 4, decimal, add a 0. 5 goes into 40 8 times. And that is your X. See, that wasn't too painful. You really can do second grade decimal long division. So your answer there is 16.8. Let's try one more. Now in this case, we're going to trace and separate, but now we're going to make side over side and solve. Now we're going to look at this, and we want to find both BD and DC. So now instead of seeing this as 2 separate triangles, we're going to see this as segment pieces. So I can do this. Watch, if this whole side is 36, we already figured out that this whole side was 45. I can go BD over 36 equals, and then the match to BD is going to be 18 over the match to 36 is 45. Now we cross multiply. Let's bring this close. Keep your hands off the calculator. Ready? When we're going to divide by 45. Now we reduce as far as we can, so we're going to go 45 and 18 first, because we know 9 goes into both, so 9 goes in here 5 times, and 9 goes in here twice. Now we have 36 times 2 is 72 divided by 5. Once again, we have long division. Don't panic. We're going to do this together. So we have 72 and we have 5. 5 goes into 7 once. 2 left over. Bring down the 2. 5 goes into 22 4 times. That's 20. Bring down the 2. Decimal, decimal. 5 goes into 20, again, 4 times. So that means BD equals 14.4. Now, we could use a proportion to solve for DC. However, this one is really easy because to solve for DC, if you trace this, you will see that DC is simply going to be 36 minus that 14.4, and that's going to equal our DC. So let's do our math. Once again, longhand without a calculator because you're just smart like that. So we're going to go 36 minus 14.4. We're going to borrow from this and make that 5. We're bringing this over, so that's going to be 6. 5 from that's 1, and that's going to be 2. So our answer here is 21.6. Now, just for kicks, let's check. So 14.4, 21.6, let's check our math. That's 10, carry the 1. That's 6, 36.0, check. We know our answers are correct.